In this example, we have a Boeing 747 that accelerates at a constant rate of 1.25 meters per second squared. It has to reach a speed of 80 meters per second in order to take off. Assuming there's a 10-second delay between reaching the takeoff speed and actually taking off, how long does the runway have to be in order to safely abort the flight right before takeoff? We're going to assume that the 747 can slow down at a rate of 5 meters per second squared. So let's write down what we've been given. We know that our initial acceleration is equal to 1.25 meters per second squared. It has to reach a speed of 80 meters per second in order for it to take off. We know that in between our velocity v1 and the time to acceleration 2, we have a time of 10 seconds. And then our final acceleration is going to be minus 5 meters per second squared. And we are trying to find the length of the runway. We're also going to include our acceleration time graph, velocity time graph, and our position time graph. To start this, I'm going to draw my velocity, position, and acceleration graphs. And I'm going to do this where I put them all together on the same axis. That way it'll be a little bit easier to transfer from one to the other. Okay, so this would be my velocity, position, acceleration. Now let's put on some points that we know. The initial acceleration is 1.25 meters per second. So this point, we'll say that's 1.25 meters per second squared. And that is a constant acceleration that goes for a little ways. Then my acceleration stops for 10 seconds, after which I decelerate at 5 meters per second squared, or my acceleration is negative. We're assuming that the airplane starts from rest and that it's going to reach a velocity at this time, whatever that time is. I'm going to draw these lines in here for my time just to help me for a reference. That at this time I'm going to have a velocity of 80 meters per second. Now, because my acceleration is constant here, and we have a straight line here, that means that I should have a slope here that's the same slope as my acceleration, 1.25. So I'll have a constant slope that goes up to the 80. Now, in order to do this, we're really going to need to find out what is the time at this point right here. Well, if this is 80, and this is 1.25, the area under this curve should equal 80. So I can say that 1.25 times t is equal to 80. Therefore, my t1 is equal to 64 seconds. So this time is 64 seconds. If I add 10 seconds to that, this will be 74 seconds. Then we're going to continue, and I probably drew this poorly, but we're going to continue this constant velocity at 80 meters per second for the 10 seconds. And then we're going to slow down, or our acceleration will be negative. Since we've got a negative 5 meters per second, my slope is negative on my velocity graph. It looks like that. So now I have my acceleration graph, and I also have my velocity graph. And this velocity, because we're coming to a stop, is 0. Now we need to find our position. Position is the area under the velocity curve. So knowing that the time is 64 seconds here, and that I'm at 80 meters per second, I can do 1/2 the base times the height of this triangle. So 1/2 64 times 80 should give me what my first position is. And that will give me a position of 2,560 meters. And my velocity is 0 at the beginning, so my slope is 0. My velocity is 80 at the end here, so my slope should be at about 80. And then I will draw a curve in there, because this is a first order equation. This will be a second order equation. And then I go at this constant speed for 10 seconds, so not very long before I have to start slowing down. So at 80 meters per second for 10 seconds. I'm at 800 meters. That would be the area of this piece. So we'll just write it in here. 80 times 10 seconds equals 800. And we add that to our 2,560. And that will give me a position of 3,360 meters. And we have a constant velocity. So that means that we will have a constant slope from this point to there. Now I'm going to slow down. So the distance I'm going to travel from the 3,360 meters to the end of the runway will be the area under this portion of the curve, of the velocity curve. And again, I'm going to need to know what this time is in order to figure out what this area is, because I don't have this base. But I'm going from 80 to 0. So the area under this curve plus this area should equal 0. Well, we already know that this area is 80, so this area should be minus 80. So minus 5 times t2 equals minus 80. So my t2 equals 16 seconds. So if I add 16 seconds to my 74 seconds, then I get a total time of 90 seconds. But because we're looking at 16 seconds from here to here, let's put this as our 10 seconds. So to get the area of this triangle, we do 16 seconds times 80 meters per second divided by 2. So 16 times 80 times 1/2. That will give me 640 meters. So I need to add my 640 meters to my 3,360 meters. And that will give me a total runway length of 4,000 meters. Now my slope here has to be 0, and my slope here is 80. So I'm going to have kind of a concave down curve. And at this point, I said I was at 4,000 meters. So the length of my runway has to be equal to 4,000 meters in order to accommodate that airplane. And that is my final answer.